A couple of things I want, yeah, go ahead. A couple of things I want to talk about. Are you coming back, Bruce?
I'll try to find out.
Okay. A couple of things I want to talk about. Some of us were really stumped by a couple of these homework problems. So this says find all the solutions. What some of you did great. You said, okay, there's an angle out there whose cosine is 0.37, and you typed that into your calculator, and you got an angle. But what you forgot was that there are other places other than quadrant 1 where the cosine could be a positive 0.37. 1.19 certainly is one of the answers. No question about that. But where else could the cosine be positive 0.37? Quadrant 4. That's still a 1.19 angle, but decimally it will be 2 pi minus 1.19. So 5.09. Now, in between, if the directions had said 0 to 2 pi, that would be it. Those are the two angles. But it says all the angles. So we need both of these along with all of their coterminal angles. Now, we're going to talk about this one more time and then I'm not talking about it anymore. Coterminal angles mean you add or subtract revolutions. You either add or subtract 1 revolution or 2 revolutions or 3 revolutions. Those are the whole numbers. 0, 1, 2, 3. So this says I'm going to add, if I let n be 0, I'm not adding anything, 1.19. If I let n be 1, then I'm adding 1 2 pi or subtracting 1 2 pi. This is how we reflect all of the angles. It's all of the coterminals. What?
I totally forgot, but did we get your birthday bonus?
No, not today. All right, here we go. Now this equation, we need to subtract the tangent because we're not allowed to divide. So we subtract the tangent, we factor it out. So tangent equals 0 or sine equals 1, plus or minus 1, because I have to square root it. All those angles are quadrantal, so I'm just going to look at my circle, and I'm going to look around the circle, and I'm going to figure out, are there any places where the tangent, which is y over x, is 0? Well, I think the tangent's 0 right there, isn't it? And right here? So that would be 0 and pi for this part of the problem. Now, where does the sine, which is y over r, where does that equal either a positive 1 or a negative 1? Here and here? Now, some of you put all 4 of those down, which means you were doing the right thing, you were going in the right direction, but what happens to the tangent at pi over 2? What is the value of the tangent at pi over 2? Undefined. This is the equation that you are solving. It has to work for whatever value of x you tell me it works for. Does this equation work for pi over 2? No, because you cannot take the tangent of pi over 2. These two are extraneous. You have to check your answers to make sure that nothing's undefined. Now, obviously I don't worry about it a cosine problem or a sine problem, but if you have any other function in the problem, you gotta check your end result. You did not need to check on your quizzes because your quizzes were all sines and cosines and they are never undefined, right? So you had no extraneous roots. You might have had wrong answers, but you didn't have any extraneous answers. But if there's any other function in the problem, you have to go back and weed those out if necessary. Okay? All right. Now we got to get back to our identities. So we're ready for this E, this huge monstrosity. So when you look at this massive problem, this thing is huge. When you look at this, you have to do something. Does anything occur to you? You notice anything that you might be able to do? Yep.
You could take out one of the cosines on the left.
Over here?
Yeah.
Okay. All right. So you don't mean take it out, you mean just split that apart?
Yeah.
Okay. So she says, I think I'm going to make this cosine to the fourth times cosine. Now, before you say, is that legal? Yeah, perfectly legal. Now, we may have no idea what she's doing, but it's perfectly legal to do that. All right. Now what? What did you do that for?
Well, because on the right, like, there's one cosine.
Okay, so I understand that logic, but what that means then is, you gotta figure out how to get rid of these.
Could you do, like, two different, like, cosine squares?
Oh, she says, I know that cosine to the fourth is cosine squared times cosine squared. Again, she's correct. Completely. And then what do we know about cosine squared? You needed this on your quiz. What do we know about cosine squared? 1 minus sine squared. So now all of a sudden, all of these cosines are gone.
You just make it over.
Except this extra one that I can't do anything with. But she planned that because she wants to have a cosine there. So now what do you think I'm going to do here? Foil it all together and then distribute. So foiling this gives me 1 minus 2 sine squared. Wow, pretty slick. Sine squared minus 2 sine to the 4th. Plus sine to the 6th, all times cosine. Good plan. Good plan. And she had a reason for doing what she did. Did everybody catch that? She said, look, I'm only supposed to have one cosine, so we'll peel that off. And as long as that the power is even, we can change it, right? We can change a cosine into a sine as long as it's an even power. So she had an even power. She said, okay, that's 2 of those guys. And then it was just foiling. Nice work. We're making progress. Here we go. Look at this guy. Now, it kind of makes you a little bit.
Common denominator.
Should we change the cosine squared minus 1 to 2 times negative sine squared?
We gotta be careful now. Let's talk about both plans. Getting a common denominator is a good idea, but I'm gonna do something I think ahead of that. Okay, that's what I wanna end up with, right? And the only thing in the problem that I wanna end up with are sines and cosines. So what if I change this into sines and cosines? So I think I'm gonna do that. Then I'll probably get a common denominator. So this is 2 sine over cosine over 1 minus sine squared over cosine squared. Now, somebody said, can we change that into a negative sine squared? And the answer is no. Because in order to do that, you'd have to be able to factor out that 2, and you can't. Now, if you wanted to, you could change the cosine squared into 1 minus sine squared, if that's what you wanted to do. May end up doing that later, I don't know. All right, let's fix this. You know what I'm gonna do? I'm gonna multiply everything by cosine squared. So I'm going to be left with, let's see, 2 sine cosine. Over cosine squared minus sine squared. Plus is everybody still with me? I'm actually kind of excited about this because doesn't that factor into cosine minus sine, cosine plus sine? And one of those is what I want to end up with. So I think I might be moving in the right direction. I just got to figure this out here. So Maren, what if we took, okay, so this is the same as cosine squared plus cosine squared minus 1. Would you agree with that?
Yeah.
And then this one, we can do what you wanted to do with before. What is cosine squared minus 1? Negative sine squared. So this denominator is actually the same as this denominator. Okay, so we cleaned this up by changing the tangents into sines and cosines. Then we took this denominator that Maren had talked about before, and we rewrote it as cosine squared plus cosine squared minus 1. And cosine squared minus 1 is negative sine squared. So now my denominators match. Would you agree? That is cool. So let's look at what we have. We have cosine minus sine, cosine plus sine on the bottom. My common denominator is cosine squared minus sine squared, which is the difference of squares. And I'm going to go ahead and factor it because this is where I'm going. Something's got to cancel. Unfortunately, nothing does at this point. I see thinking anything? Except, get me out of here.
Make 1 cosine squared plus sine squared.
Yes! Sammy, that's awesome! 1 is cosine squared plus sine squared. So I'm gonna write that in the numerator. And I did split it. I split it and put cosine squared here in front and sine squared at the bottom, but that's my 1. Now, what is so cool about that, Sammy?
It can cancel now.
Well, nothing cancels until it factors.
Oh yeah, you can factor it.
You can factor it. How does the top factor?
Could you?
Cosine plus sine?
Yeah, cosine minus.
Cosine plus sine?
Oh, plus sine. Okay, that yeah, because you gotta keep something. Okay. I see. This is wild.
What about your 2?
How does that factor, Mary?
X plus Y is
What happened to the 2?
in there.
It gets absorbed when you FOIL it back out, right? Yep. The regular factoring problem. Regular factoring. And what happens now that we got it factored? Now we can cancel. And we are left with what we wanted. Okay, we have had 2 really good ideas today. You guys are awesome. That is phenomenal. Keep that up. Good job.
Okay,
Wait, what
since
if it's
I
two cosine,
related a little
two
bit
sine
to
x
numbers,
plus
how do you
sine?
know the difference between like
What if I just
0 or 360, like on the like circle?
Okay, we never say 360, we always say 0. You always answer with the smallest angle.
So what about like 2 pi? Like if it was like,
So we always answer with 0.
so it's always 0.
Yeah.
Would be counted wrong if you put 2 pi.
Well, it's not, the directions are 0 to 2 pi. What does that parentheses mean?
Yes, it would be wrong. Okay.
Not
whole thing got
included,
factored, I
right?
see.
Okay, yeah.
Yeah. Let's not worry about that. If you got, if 0 is one of the answers and you wrote 2 pi, you know what you're doing. Okay? So let's not sweat about that. Okay, so let's go back and recap a little bit on that problem. I know I had to erase it, I'm erasing it now. But what was the first thing we did, if you recall? We changed our tangents. Now, what was our logic? Why did we think about changing our tangents? Because this is what I was trying to end up with, right? Now again, there's lots of ways you can do it, but if we're trying to figure out like how to get to point B, look at point B and say, oh, there's no tangents in there, so let's get rid of the tangents. I also like Marin's thought. She saw that, whatever it was, sine squared or whatever, cosine squared, she saw that and immediately thought, I can change that into a sine squared. That's another thing we did, and it happened to work. It worked out for us. All right, what's next? Now this is, we did one like this the other day, and I cautioned you, and I'm gonna caution you again. You don't know that this is an equation. That's your job. Your job is to prove, verify, that it's an equation, an identity. Okay? So we're not cross multiplying, because what's our rule? We change one side, only. So I don't care which side you change, but only one. If you cross multiply, you're gonna end up changing both sides. Not allowed. Okay, Lucy?
I was gonna say the first step, I think.
Sure, I'm ready for
Can
it.
I multiply the top and the bottom, like from the right side, the top and the bottom by 10x?
Here, 10x. I think that's a great plan. We did this the other day, and what was our logic? Why did we just all of a sudden say, oh, I think I'll multiply top and bottom by tangent? Because if I'm working over here, don't I wanna have a tangent in my numerator?
Hmm.
So she says, I'm gonna stick one up there. Okay, well, let's see, what happens when I do that? Well, it makes my denominator tangent squared. Is there anything that makes me happy? Sarah?
Well, doesn't secant x minus 1, does that equal tangent squared?
Not unless it is
Square.
squared. So,
Oh.
Sarah, back up. Same idea right here. You have a squared right here.
Yeah.
What's tangent squared?
Secant x minus 1.
Secant squared minus 1. So let's do that. Let's use your thought. But I have to only change, I can only change a squared. So this is, let's see, I always have to write it down. 1 plus tangent squared is secant squared. So tangent squared is secant squared minus 1. Now, this is where we are. That's where we want to be.
Can't you factor out?
Oh, yeah.
Like the difference of two
Oh, yeah.
This is the difference of squares, right down here on the bottom. Kids, you're going to do that in half the problems you do. Because every time you use the Pythagorean identity, you're going to have a difference of squares somewhere. So that factors. And what happens as soon as I factor? I can cancel, and what am I left with? Tangent over secant minus 1, which is what we wanted. Now, I am a huge proponent of changing into sines and cosines. I change into sines and cosines all the time, but not in this problem. Because in the original problem, didn't both sides have exactly the same two functions?
Yeah.
So if I decided to change into sines and cosines, which I could do, I eventually would have to just change them back. So it seems more practical just not to change them this time. Tess?
Will you ever give us one that doesn't?
Yes, we already discussed that. Not yet, but that day is coming, and we'll talk about how we know, okay? All right, H. Cosecant over sine minus cotangent cosecant over secant equals 1. So, basically what has to happen in this problem, would you agree? What has to happen is everything's gonna cancel out. All this mess has to just boil down to 1. Okay? So, anyone have a thought?
Change it into sine and cosine.
I like that idea. I like that idea. This one I'm gonna try to shortcut a little bit. What do I know about cosecant?
1 over sine.
It's 1 over sine. So if I have a cosecant on top, isn't that gonna be a sine on the bottom?
1 over sine.
So this is just gonna be 1 over sine squared. I'm not gonna mess with that. This is kind of a mess, so I'll just do it. Let's see, cotangent is cosine over sine times 1 over sine over 1 over cosine. Okay. So what do you want to do with that? Now, remember that, that numerator is cosine over sine squared because,
Wait, why wouldn't cosecant divided by sine cancel out? Because if cosecant is 1 over sine and then you divide it by sine, You'd be multiplying it by the reciprocal.
They don't cancel. Sine cancels with sine. Sine doesn't cancel with cosecant. Okay, let's put our thinking caps on now and let's come back. Somebody said, let's clean this up. Now, because this is such a simple fraction and we're dividing by 1 over cosine, can I just say that's the same as multiplying by cosine over 1? So I have 1 over sine squared minus cosine squared over sine squared. Because I took cosine over sine squared and divided it by 1 over cosine, which is cosine over sine squared times cosine over 1.
So we're multiplying everything by cosine?
Yeah. And sine squared. If you do it that way, you have to multiply by both of them.
That's 1 minus.
All right. What do you notice here?
Combine them.
We can actually put them together because they already have a numerator or a common denominator. And what do you notice about the numerator?
It's sine squared.
Oh my gosh, so we have sine squared over sine squared, which
No way.
is 1. All right. Let's look at a couple more. I think that's it in the notes. I'm going to do a couple more. So let's look at this one.
Just scrap it.
Wait, can I take a picture of that?
Yep.
Yeah, I love that.
Okay. You maybe can't see that. This is sine 4 minus cosine squared equals cosine 4 plus sine squared. All right, you'll just need a separate sheet of paper to do this one. So this is cosine to the 4th plus sine squared. Okay? So what are you thinking when you look at this?
Could you make that cosine squared times cosine squared plus sine squared?
This one here?
Yeah.
Absolutely.
Make it 1.
She says, look, we got some really good ideas flowing today, that's great. She says, look, I only need, well, I don't know exactly, what are you thinking? You're thinking you need this to be a sine to the 4th? Well, is that what you're thinking?
Yeah, I don't know.
Well, let's try this. What if we changed these guys into sines? Won't that give me a sine to the 4th if I change them both into 1 minus sine squared? And then I can change this one into 1 minus cosine squared, and that'll give me, that looks good. That looks good. So, your identity is for squares. So she split this into 2 squares and then changed them both into sines. Then she changed that one into a cosine. It was a square, she changed it into a cosine. So let's see what we've got. If you FOIL this out, that gives her her sine to the 4th that she was hoping for. This looks really good. What else do I have though? 2 minus 2 sine squared. Now I'm not touching this part because that's exactly what I want. What about this? What can I do with that?
Factor out of 2.
Factor out of 2. And that'll leave me with 1 minus sine squared. So that's 2 cosine squared, would you agree with that? Plus sine to the 4th minus cosine squared. Well, these add together, don't they? And that's gonna leave me though with sine to the 4th plus cosine squared. Is that what I'm left with? And what do I need it to be? There's an example of a non-verifiable, that's not an identity. That is not an identity. Because there is no way to make sine minus cosine equal to sine plus cosine all the time. That just isn't a true statement. 5 minus 2 is not 2 minus 5, right? Or 5 minus 2 isn't 2 plus 5. Can't be done. There's an example. We'll do another one. All right, here we go. Write this one down. We're going to try to verify this. Here we go. Anybody have a thought?
Can you flip the cotangent?
I would. When I see a 1 over cotangent, doesn't that kind of just scream at you? I'm a tangent. So let's write that as tangent to the 4th minus tangent squared. Now, I have even tangents, even powered tangents, and even powered secants. Do they connect? Because 1 plus tangent squared is secant squared, right? So I'm going to think of this as tangent squared times tangent squared. Now, you could, let's just do it. So what's tangent squared gonna be? Secant squared minus 1. And I'll just change them all.
Wait, wouldn't you?
Alright, so what happens when I FOIL this? I'm gonna get secant to the 4th minus 2 secant squared plus 1 minus secant squared plus 1. Alright, what do I end up with here? Looks like I've got secant to the 4th minus 3 secant squared plus 2.
Factor it?
Good idea. So this is secant squared minus 2 minus 1, is that right? Now, I know you're not supposed to change the side, and we're not gonna change it, but I want you to think about this side over here for a minute. Think about that for a second. Can you factor that side? Yeah. And if you did factor it, wouldn't it look like this? And this is common to what we wanted, right? That part's good. But the only way this would be true is if plain secant squared is the same as secant squared minus 2. Can that be? Can x squared equal x squared minus 2? No. So this is another example because the parts simply can't be made to match up. All right, now we're going to close out with one that does work because I don't want to leave you on that.
So do you have to, like, when you're finding, like, when you're solving one like this where it's gonna end up being not verifiable, like, it doesn't work, you can't, it's not, like, true, do you, like, once you factored it down, I mean, like, there's kind of more you could do you have to, like, go and look at what it's supposed, like,
Well, I need a next step after that.
right,
Yes, I'm always looking at what I have because I need to turn it into that. All right, last one. We haven't done one with 2 variables in it. So let's try one with 2 variables. Now, the only difference here is, you know how when we had, like, example, when we had a cosine squared and a sine squared, we just automatically made that 1 because it is. But it's only 1 if these guys are the same. So if we encounter, or another example would be, if you had sine theta over cosine x, that is not tangent. Because it can only be tangent if the angles are the same. So before you start combining or simplifying, just make sure your angles are the same. So what do you think about this one?
Change our secant and cosecant to
That's a great idea. See, you guys know what to do. Yes, you do. You let yourself get psyched out. You get all panicky because every problem is different and you're not going to memorize your way out of this. You're going to have to plow through them. All right, what do we got here? A huge, giant, yicky, complex fraction.
common denominator.
I'm going to multiply by cosine theta sine A. Cosine theta sine A. Cosine theta sine A. Cosine theta sine A. Now my purpose for doing that is to get rid of every denominator in the problem. Well, there weren't any denominators on the top, so I'm going to have cosine squared theta sine A minus cosine sine A squared. That's what I've got on the top because absolutely nothing cancels out. Now down here it does cancel, so I'm left with sine A minus cosine theta.
Couldn't you, yeah, so you could factor the numerator.
Okay, what can we take out? A GCF? So cosine sine, oh, the thing I just put in. Take that out, and I'm left with cosine minus sine.
I was gonna you could do it, I was gonna say to do it like, I don't know if this would even work or help at
Okay,
all.
well, let's finish this first, because we're about done here. What do you notice about these two things right here? They're
got
the
a
same, but negative. It's like having a 7 over a negative 7. You can cancel them, but you're left with a negative 1. So I'm going to cancel those out, and I'm left with a negative 1, which lo and behold is exactly what I wanted. Okay? Now this is what I call the meat and potatoes way to do the problem. There's no cleverness here. I'm not trying to be tricky. We changed into sines and cosines, multiplied to clear the fraction, and factored. You know how to do all those things, right? All right, 5-2 is finished. That homework will be due on Tuesday. I encourage you, if you have any time over the weekend, pull out this extra packet thing I gave you. There are so many problems on here. You could spend 48 hours on this.
CPM.
Mrs. Ford, are you in here during the period?
I have a class.